I've seen online a lot is biological age. It's a term that's been thrown out there. What is the difference between biological age and the amount of candles on my birthday cake?
Yeah. So, how old you are, how many years you've lived, doesn't really correlate with how healthy, how fit, how strong, how mentally sharp, how good you feel or how free from disease you are. Biological age does. These types of biological age clocks, you call them. The most accurate ones are DNA methylation clocks, and that is literally epigenetics. We're measuring the gene expression in your adult body. That is measuring how well your genes are currently expressed. And biological age is what determines basically your risk of disease. And we're talking about all-cause mortality, and then especially all the major diseases that people end up with and that are chronic diseases. Your risk of those is lower, a ton lower, when you're young, when you're 20 years old. You simply don't have very many 20-year-olds get cancer, and you have more 75-year-olds that get cancer. This is literally because of their biological age. If we took a 75-year-old and measured their biological age and it said that they were 56, or we did the different things to reduce their biological age, their risk of having cancer, for instance, is that much lower. And when we measure that stuff, it's all epigenetics. It's all DNA methylation. So the way this works is we have, this might get a little complicated, but it's upstream regulation of gene expression. So we have chemical caps that sit on the genes basically and protect it from being read. Along comes RNA and tries to read that, but it's protected so it doesn't read that. When I talked about cell differentiation, if you've got a skin cell, all the skin genes are on, you've removed those chemical caps, RNA reads that, produces the skin proteins. As we age biologically, and this is through life, through damage and lack of repair and so on and so forth, we end up with genes that are incorrectly expressed in the same cell. Take a skin cell, for instance, and this is a really good example because it's visible. And you have that skin cell and it gets damaged, say by UV light. And now the proteins that are getting produced off of the DNA in that cell, it's incorrect. And so you've removed some of these methyl caps off of other genes. Improper genes are being expressed. It still kind of looks like a skin cell, kind of behaves like a skin cell, but it isn't, and it starts to divide. And what do we call that on our skin? A rash. These are a bunch of cells that kind of are confused, don't know what they're supposed to do, and they're not functioning very well. And that's how it relates to your health outcomes. And that's exactly what we're measuring when we're measuring biological age. It's the DNA methylation, it's epigenetics in your whole body, and we're doing that on a system-by-system basis so we can identify which systems are keeping up with regeneration and which ones are failing to keep up.
And how is that tested?
So it's this simple, either a finger prick,
Okay.
and we get a drop of blood out of your finger, or it depends if we're doing some other things. We'll draw a couple tubes of blood. We just need a couple drops of blood really for that. Yep.